Welcome back. This is section 12.5, and we are going to be talking about parabolas. So we are finishing up our conic sections, and this is the final one, which is the shape of a parabola. So you can see the picture there of how the parabola is created. And a parabola, when we construct it on the graph, it's the set of all points in a plane that are equidistant from a fixed line and a fixed point. So the fixed line that we have down there is called the directrix, and the fixed point is called the focus. So if we look at our picture over on the right, we can see that we have that focus point and this directrix line, and the parabola is made up of all the points that are equidistant from those 2 points. So another way to think of that is that the distance from the focus to the point, that's d1, and the distance from the directrix to our point they're equal for any point xy on the parabola. So no matter where I put a point on that parabola, it's going to be the same distance from the focus to that point and the directrix to that point. So that is how a parabola is constructed. We are going to look at some key features of it now. So here's a couple of pictures of parabolas, and you can see that they can open different ways. So we have horizontal parabolas that open left and right, and we have vertical parabolas that open up and down. So let's look at some of these key points here. I'm going to zoom out slightly so we can kind of see everything at one time as we go through this. So let's talk about how we would create these equations that'll give us a graph of a parabola. So when our parabola is horizontal, which means it opens left or right, so let's fill that in. That kind of parabola is created from an equation that says x minus h equals a times y minus k squared. So we've looked at parabolas possibly before in quadratics. You've seen those in other courses and previously in this course. And so you'll notice that squared, it's similar to that, but this time it's a parabola from a conic section. So it has a little bit different when it's opening in different directions. Now, if the parabola is opening vertically, which is maybe what we're more traditionally used to, that means it's opening up or down. And the equation for that one shifts so that the y is on the left side of the equation. So we'd have y minus k equals a times x minus h squared. So those are the equations that we would use to create these different parabolas. Let's talk a little bit about where some of those things are coming from. So as a reminder from before, we have this center point on the parabola, and that is called the vertex. So you can see it in both of them over there. And when we have a vertex, the coordinates of that vertex are h and k. So that's where the h and the k are coming from in the equation. And then we'll talk in a minute about where the a is coming from. So some other key points on our graph here. So we have that focus. Remember, that's the point that is inside the parabola. And that's one of the distances that's always equal in a parabola. So the distance from the vertex to that, or from any point, not just the vertex, but any point on the parabola, that distance to the focus is part of what keeps the parabola shape what it is. And then we have that directrix that we talked about before. So the directrix is a fixed line. So we can see it in our pictures up above. It's a dashed line is what we usually use to represent it, that always lies outside the parabola. And again, that focus and the directrix are what our points on the parabola are equidistant from. All right, and then we have what is called an axis of symmetry. You've seen this before when you've talked about quadratics before. So then axis of symmetry is the line that passes between the vertex and the focus. So it's that line that kind of goes down the middle of the parabola so that what's happening on one side of the parabola is equal to what's happening on the other side of the parabola. And then when we think about where that focus is, we have something called the focal distance. So the focal distance is the distance between the vertex and the focus. And that distance we represent with the letter F. So that focal distance we write as plus or minus F, depending on which direction it's going from the vertex. So that is the distance from the focus to the vertex, and it also then is the distance between the vertex and the directrix. So the last thing we need to talk about here is how to find that A value in the equation. So remember, A is what's out in front of our quantity that's being squared. And what we're going to do to find that, the formula for it, is to take 1 and divide it by 4 times that focal distance. So 1 over 4f is how we find the A value. The A value kind of helps us determine how wide or how skinny or how stretched or compressed that parabola is. So the A value also tells us which way the parabola is going to open. So if A is less than 0, so it's a negative number, that tells me that my parabola is going to open to the left, or it's going to open down, depending on if it's a horizontal or vertical. And then the opposite is also true. If A is greater than 0, so if it's a positive number, my parabola is going to open to the right or upward, depending on if it's horizontal or vertical. And then one other thing we need to just know, that focal distance that we have here, if we don't have the graph and can't just count it, we can find that focal distance by doing 1 divided by 4 times A. So depending on whether we're given the equation or given the graph, we can use those formulas to kind of figure different parts out. So we're going to use all that information now to start figuring out some key features of some parabolas on graphs. Okay, so in example 1 here, we are given this graph. I can see some key points over there. I can see this point, and then I can also see this point on the inside of the parabola. So we're going to use those to kind of start helping us. So I can tell from my picture here that this parabola is opening downward, which means it's a vertical parabola. Anything opening up or down is vertical. And based on where those 2 points are, the yellow point that I highlighted is the vertex, and the red point that I highlighted is the focus. Based on those 2 points, I can then see where my axis of symmetry is, because remember, the axis of symmetry is always going to be that line that goes between the vertex and the focus. So if I draw my axis of symmetry down those 2 points, I can see that it's at the x value of 2. So my axis of symmetry is the line x equals 2 because it goes between the vertex and the focus. All right, so in order to write my equation, I need that vertex point, but I also then need my A value. So remember, we talked about a formula to find that A value. So to find that A value, we do 1 over 4 times, and remember, F is the focus distance, or the focal distance. So that's the distance between those 2 points, and I can see from 1 to 2, that is a distance of 1. So 1 over 4 times 1, that means my A value is 1/4. Since this parabola opens downward, I know that it's going to be a negative 1/4 A value. That's what makes it open downward, is making it negative. So knowing all of that, knowing that it's a vertical asymptote tells me that my equation is going to start with y minus the y of the vertex, which is 2. And then that's going to equal the a value, which is negative 1/4, times x minus the h, or the x of the vertex, which is 2 squared. So those key features help me to write the equation of my parabola from that graph. Let's look at one more example here. So again, in this example, I can see that I have a vertex point and I have a focus point, and I can see that they're very close together, so that's going to kind of give me some clues about how to write my equation. This particular parabola I can see is opening to the right, so that makes it a horizontal parabola. So my axis of symmetry is going to go right through that vertex and focus. So when I draw a line that goes through those, I can see that it goes through the y at 10. So my axis of symmetry is the line y equals 10. Once again, we have to find that a value. So I'm going to do 1 over 4 times that focal distance. And if I look over here, they're a little close together, but I can see that the distance between those, it's going from -1 to -3/4. So that distance is 1/4. So the focal distance, or f, is 1/4. So my equation would look like 1 over 4 times 1/4, and that would make 1 over 1. 4/4 is 1. So my a value is 1, and since this parabola is opening to the right, I know that it stays positive. If it was opening to the left, I would make it negative. So using all that information, it's a horizontal parabola. So it starts equation with x plus the x of the vertex, or sorry, minus the x of the vertex. But in this case, since my vertex point is at -1, it would be minus a -1. So I'm going to write that as +1. My a value is 1, so you can write the 1 in there. You don't have to, since multiplying by 1 does not change the value. And then I'm going to do y minus the y of my vertex, which is 10, and square that quantity. So again, your equation can have that 1 a value, or you don't have to write it. Either equation would be right. Okay, so then our last thing that we're going to do is we are going to be given an equation, and we are going to graph the parabola. So let's look at example 3 here. And when I look at example 3, I can see a couple of key things. So I can see first and foremost that it starts with x minus 2. And since it's starting with its x minus 2, I know that that means that it is a horizontal vertex, so going along the x-axis. I can also tell from this a value, since it's negative, that means that my parabola is going to open horizontally to the left. If it was positive, it'd be opening to the right. All right, next up, I can use my equation to find my vertex point. So remember, the vertex comes from the h and the k, which are the x and the y of the vertex. So that vertex would be at 2, and the y coordinate would be at 3. All right, so if I know, and you can kind of use a sketch to help you if you need to before you actually formally graph it. If I know my vertex is at 2, 3, and it's opening to the left, then I know my axis of symmetry is going to be a horizontal line. So it's going to be at y equals, and remember, it has to go through that vertex point. So it has to go through the y value of 3 based on my vertex. All right, and then we just need to find our focus and our directrix. So remember, to find that focus, I have to find the focal distance first. So I'm going to do 1 over 4 times the a value, which in this case was -2 up here. So that gives me a focal distance of 1 over -8, or -1/8. So what that means is my focus is -1/8 from my vertex. So if I go -1/8 from 2, that means that my focus is at 15/8, right? So 2 is 16/8. If I subtract an 8 from that, I'm at 15/8, and it has the same y value. So my focus is at 15/8, 3 on my graph. And then my directrix, remember the focus and the directrix, the focus is on the inside of the parabola, the directrix is on the outside of the parabola. So that means my directrix is 1/8 the other direction. So that means I'm going to add, that means that my directrix is going to be at 17/8. So 1/8 more than 2. And since my directrix is going to go the opposite direction, I know that it's going to be an X line. So when I put all those things together, I get a graph that looks like this. So you plot your vertex, you plot your axis of symmetry, and you can plot your focus and your directrix, and then make your parabola based off of that. All right, and then our last example is another equation that we are given, and we're going to use that to help us find all of our key features. So in this one, I can start off by seeing that it is starting with y minus 2. So that tells me that it is a vertical parabola. And since the a value is positive and it's vertical, that tells me that it's going to open upward. And then I can start finding the key points of my vertex. So I notice that the y has a minus 2. And then I notice that the x doesn't have anything attached to it. So that means that the x coordinate is 0 and the y coordinate is 2. All right, so again, it helps me to just kind of make a rough sketch to start with. So this parabola is opening up. It has a vertex at 0, 2, so it's going like that. So that tells me that my axis of symmetry is going to go right down the center, which means that it is going right through the x value of 0. All right, so I know where my axis of symmetry is. I know where my vertex is. So now we're going to find that focal distance again so we can figure out where the focus is compared to the vertex. So I'm going to do 1 over 4 times a. My a value again from the equation is 1/2. So that's going to give me 1 over 2, which means that my focus is 1/2 away from the vertex. And since this one's vertical, it's going to be in the y direction. So that means that my focus is at 0. And then if I go 1/2 above 2, I'm at 5/2. And then my directrix, again, is going to be in the opposite direction. So if I go 1/2 below my vertex, then it's at the y value of 1.5 or 3/2. So plotting that all on the graph would give me a graph that looks like this. I've got my vertex there at 0, 2. The focus is 1/2 above it. The directrix is 1/2 below it. And I've got my axis of symmetry going down the middle. All right, those are your parabolas. We'll see you next time.